First question, and pay attention because these will require attention if you don't know about the trends or if you are not confident about the trend. In which of the following arrangements the order is not correct according to the property indicated against it? Al3 plus, Mg2 plus, Na plus, Fi minus. When you see these type of species, first thing which you should come in your mind is whether these are isoelectronic species. Isoelectronic species means total number of electrons will be same. Aluminium 13, magnesium atomic number 12, sodium 11, fluorine 9. Aluminium after losing 3 electrons, 3 plus means it has lost 10 electrons. Mg 12 after losing 2 electrons, 10. Sodium 11 after losing 1 electrons, 10. Fluorine minus means it has gained 1 electron. After gaining 1 electron, 10. It means these four are actually isoelectronic species. Okay. And isoelectronic species, you need to remember the trend. The trend is that the size increases with negative charge. So for isoelectronic species, size is proportional to
Oh, wait.
negative charge. And the reason is very simple. If it has lost electron, for example, L3 plus, and it has 13 protons, so 13 protons still will attract the remaining 13 protons will still attract the remaining electrons with greater force. Okay? But if you consider F minus, there will be interelectronic repulsion. If one electron comes here, there will be interelectronic repulsion. Moreover, it has only 9 protons. 9 protons means less force of attraction. But you need to remember this because this will be asked as it is in objective questions. Isoelectronic species, if you find, amongst them, size will be proportional to negative charge. It means it is correct. Negative charge is increasing in these isoelectronic species, plus 3, plus 2, plus minus 1. Okay. So positive charge is decreasing. It means negative charge increasing. So this one is correct. No problem in this one. We have to find the one which is not correct. Hence, it is not the answer. So this is correct, hence not the answer. Now the next one, boron, carbon, nitrogen, oxygen, increasing first ionization enthalpy. Now we are talking about increasing first ionization enthalpy, and it should be like boron, carbon, nitrogen, oxygen, because these are in this uh, fashion in increasing order. After boron, you have carbon, nitrogen, okay, 5, 6, 7, 8. But nitrogen has a specific stability due to half-filled configuration. 1s2, 2s2, 2p3. So this 2p3 has half-filled configuration due to which it is stable and more energy is required to remove the electron. First ionization enthalpy means you need to remove the valence electron. So it means it requires energy even greater than oxygen. So the trend is not BCNO, rather it is BCON. These two swap their positions. Nitrogen requires more energy than oxygen due to its stable configuration. So because this trend is wrong, this is the correct answer. If anything is not clear, let me know, okay? Then the third one, although we have got the answer, but C and D I am discussing. The halogens are given, sorry, increasing order of electron gain enthalpy. Normally, yes, if you see fluorine, chlorine, bromine, iodine, it should be in this order: fluorine less than chlorine, less than bromine, less than iodine. But there is exception here. We talked about it, electron gain enthalpy, because fluorine is very small atom. When it gains one electron, there is higher inter-electronic repulsion. So it is not stable, much stable after gaining one electron. Hence, these two swap their positions. So it is chlorine, then fluorine, then bromine, then iodine. So it will be chlorine less than fluorine, less than bromine, less than iodine, increasing like which is given here. Okay. So it is talking about negative, so it will release. So in that case, it will be opposite sign here. Chlorine, you will have maximum, then fluorine, these will swap their positions. Okay, trend will be same, but sign will change. Bromine, iodine. So the highest electron gain enthalpy in the periodic table is of chlorine, not of fluorine. However, fluorine is most electronegative element. The difference should be very clear. If we talk about electronegativity, there is no exception here. Okay? Electronegativity, fluorine. But electron gain enthalpy, there is exception. So because this is correct, hence not the answer. Now the last one, lithium, sodium, potassium, it is rubidium. Increasing metallic radius. When we move down the group, metallic character increases. And it increases because of simple theory that the ionization enthalpy decreases. Higher the ionization, easier the ionization, you can say, higher the metallic character, because it will be able to give its electron for movement. That is, metallic character is actually how it can pass the electricity. Both are proportional. So if you see that it can lose electron easily, it means those electrons can conduct electricity, metallic character will be higher. These things are interrelated. So lithium, sodium, potassium, rubidium, okay, cesium, francium, like this. In this order, the metallic character increases. There is no exception here. Correct statement, hence not the answer. Only B is wrong. That's why B is the answer. Next one. The increasing order of first ionization enthalpies of elements of boron, phosphorus, sulfur, and fluorine. Lowest first. Obviously, if it is increasing order, lowest you will write first. So here, if you see, this is how they are placed in the periodic table. In the periodic table, phosphorus, sulfur, boron, these four are placed like this. And if we are talking about first ionization enthalpy, the ionization enthalpy increases due to decrease in size. Size decreases across the period, hence increases. And in this, it ionization enthalpy decreases. So with this trend, you can get the answer basically. It means boron has to be the first one probably, isn't it?
Yes, sir.
Just few answers I have received. Just let me see. Okay, Yash, fine. Um, right, right. So you have got the point, Yash Bedi. Good. Mm, okay, okay. I'm explaining it. Okay. So normally you will see that you will say that if this is the vector, it should be vector sum should be like this. If these two vectors are added, vector sum will be like this. Means boron should have minimum and probably sulfur or fluorine should have maximum, and phosphorus should be after bromine. So it looks like that it should be like after boron you should have, if you move in this direction like this, you could have phosphorus, then it will be sulfur, then it should be like this. Okay? If we are talking about first ionization enthalpy. But first ionization enthalpy, we talked about nitrogen and oxygen. If you remember that nitrogen, due to its half-filled configuration, is more stable. The same thing is true here also between phosphorus and sulfur. 15, 16. atomic number. Okay, 1s2, 2s2, 2p6, 3s2, 3p3, 15. Okay, so it has half filled configuration again. Nitrogen has 2p3, phosphorus has 3p3. So due to that, this is swapped. Sulfur comes first, phosphorus moves up. Remember, all most of these trend based questions will have exception there, but not necessarily. So be cautious. Effectively, the answer will be C, not B. Otherwise, it would could be B, but there is exception. That's why it is C.
Sir,
Yes.
sir, it means that both electron gain enthalpy and the ionization enthalpy are directly proportional to the stability for a given element.
Everything is related to stability, first of all. But in this case, if you're
Yes,
talking
sir.
about ionization
Sir,
enthalpy and electron
comparative
gain enthalpy,
values.
yes, ionization enthalpy is more related to that how stable it is prior to ionization and after the ionization. However, electron gain enthalpy is more related to that after it gains the electron, how stable it is. Okay, so that's why the
Okay, sir. Okay.
exception is there with fluorine, because after gaining the electron, it is less stable. So that's
Yes,
why
sir.
its electron gain enthalpy is less than fluorine.
Yes, sir.
So why I said in case of ionization enthalpy, it depends on both, because suppose you consider Na, sodium. Sodium after losing the electron gains noble gas configuration, neon. Na plus has 10, neon 10 electrons. So ionization enthalpy after losing the electron. But for nitrogen and phosphorus, for example, before losing the electron, because their configuration is stable before losing the electron. So ionization enthalpy, both. But electron gain enthalpy normally will be exceptions. I am talking about exceptions will be normally based on when it gains the electron. Next one. The correct order of ionization enthalpy of carbon, nitrogen, oxygen, and fluorine is. You should be able to answer this question. Hmm. Yes, good. Karthike, that was previous answer. Yash, Bedi, Kavish, both correct. Good. Samad, Amir, Atman, good. Karthike, good. Ariman, again. We have talked about this exception. We should be able to answer. Arna, good. Yes, normally it should be carbon, nitrogen, oxygen, fluorine, 6, 7, 8, 9 atomic numbers. But we talked about that nitrogen is more stable than oxygen, so it will require higher energy. So both will change their position. Nitrogen will go after oxygen. So it will be CO and F. Yeah, the same point which we discussed. Nitrogen has stable state configuration 1s2, 2s2, 2p3. So will require greater amount of energy. Next, the set representing the correct order of ionic radius is, and this is something I have told you, the rule. The rule I have already told you. But still, rule, apart from rule, you need to use some other concept here as well. Lemuel, correct. Apart from that, you have to consider So this is actually trend-based question. If you know the trend, you will be able to answer it. Devyansh, no, sorry. Yash Vedi correct. Karthikeya correct. Good. Sanskriti correct. Samad, think again. Samad, how could lithium be greater than sodium? Lithium just 3 atomic numbers, sodium 11 atomic number. Lithium is in second period, sodium is in third period. Okay, Kavish, Amir, correct. Good. So for this one, if you see the trend, and we are talking about ionic radius is just when it loses one electron, otherwise it is will be normally what is atomic radius. So the radii decrease across the period and increase. So basically, I can say increase in this order. Left to right decrease, right to left increase. Yeah. It means if you add these two vectors, these are the two vectors. If you add these, you get resultant vector like this. Isn't it? Okay. So it means the greatest one here, it is given in decreasing order. So in decreasing order, it will be opposite. Okay. Means sodium will be the largest. This gives you the answer B. But yes, you need to consider other as well. Okay. That which one is correct, which one is not correct. Okay. So you might think whether you need to go like this, decreasing order, or you need to go like this. This one is largest, this one is the smallest as per the trend. You know that, okay, as per the arrow. But from sodium to beryllium, we can go in two ways. Okay, the first one I told you, and another one can be first you go to magnesium, and then it can be lithium, and from lithium to beryllium. Okay, so in reality, you need to remember the magnesium after losing two electrons, it is not just Mg plus, Mg2 plus. Okay, now see, when it loses two electrons, why its radius becomes less than lithium? Because lithium is just, you know, 2 comma 1, but magnesium is 12 electrons, so 12 protons. Here only 3 protons, 12 protons. And when it loses 2 electrons, its configuration is only 2 comma 8. Its configuration is 2, but it's 2 comma 8. And now this shell, second shell, is attracted by 12 protons. Okay, 12 protons. So the force of attraction to the valence electrons is very, very high, even higher than what these two electrons get by these 3 protons. So in lithium, you have 3 protons and Li2 plus only 2 electrons. So there will be some force of attraction. But this force of attraction will be by only 3 protons. In case of magnesium, there are 12 protons. Okay? And you have first shell and second shell also. Here you have 2, here you have 8. But what happens? These 12 protons attract these 8 valence electrons with such a greater force that effectively it becomes less than lithium, which is something as exception you need to remember. So lithium plus, although has just one shell, lithium plus, lithium will have 2 comma 1, lithium will be just 2, lithium 1s2, 2 electrons only. Mg2 plus will have 10 electrons, 1s2, 2s2, 2p6. So here valence shell is 2, here valence shell is 1. But still Mg2 plus is smaller in size due to very high force of attraction. So remember it, it will be asked quite a few times. Otherwise, there will be mistake. So answer will be B. Next, which of the following order regarding ionization enthalpy is correct? You have already done it, so you should be able to answer it very good. Just see the signs first, okay? Where it is greater than, where it is less than. Ariman correct. Samad, Devyansh, think again.
Sir, I didn't answer.
You didn't answer
Sir,
it.
those were the answers for the
That was for
previous
previous.
question.
Okay, okay. So answer now. Okay. Pratham correct. Yash Bedi correct.
So,
Yes.
sir, I have a doubt in the previous question.
Okay. After this question, I'll go back. Atman, no. Kavish, yes. Subway, yes. This question is now very easy because I have discussed it when I discussed carbon, nitrogen, oxygen, fluorine. Arna, yes. Samad, yes, right. So instead of NOF, these change their position. Okay. So oxygen is actually less than nitrogen, less than fluorine, but it is written like this in this case. Okay. That nitrogen is greater than oxygen, fulfills here, and fluorine is greater than oxygen, again fulfills here in both cases. Nitrogen greater than oxygen, fluorine greater than oxygen. C is the correct answer. Devyansh, yes. Janendra, Shivani, good. In this case, C will be the correct. Now, in previous question, yes, where the confusion was.
But like, if lithium and magnesium are not in their excited states, can we consider their sizes to be equal?
No, it is not excited state basically. They have lost the electron and these are not in excited. These are in ionized state.
Yes, sir. So, can under normal conditions, can we consider them to be equal?
No, in normal condition, magnesium has greater size as compared to lithium.
Okay, sir.
Okay. Next question. And this is a specifically important question, appears many a times in your school exam. The first and second ionization enthalpy means to remove the first valence electron, and once you have removed that electron, after the next electron you remove, then the energy. These are two energies. Ionization enthalpies and the electron gain enthalpy are given for few elements. You don't know what these elements, element 1, 2, 3, 4, 5. So to remove first electron from these elements, this much energy is required. Then to remove next electron, valence electron, this much energy is required. And this is the electron gain enthalpy. Means in their neutral form, if they gain one electron, this is just change in electron energy. Means in these cases, energy is released, but in this case, you have to provide energy. So the question is, most reactive metal and the least reactive non-metal are respectively. Yes, Bedi, correct answer. Others, right? Okay. Lemuel, no. Kavish, no. Sabri, no. Ariman, no. Pratyush, no. Ilham, no. Samad, yes. Most reactive, now I'm giving you a hint. Most reactive metal will be that one which can lose the electron very easily. The first electron, it will lose very easily. The non-metal and least reactive will be that one. Non-metals are towards the right hand side of the periodic table, means they can't lose their electron. They can gain electron. But if they are non-reactive, even they should not be willing to gain electron. They should not lose the energy. They should rather require energy. Now tell me the answer. Okay. Now Vedant, Kartike, Sabri, correct. Aryaman, no. Kavish, no. Amir, yes. Okay, now look here. If I'm talking about most reactive metal, metals are towards left hand side, and if it is very reactive, it should lose electron very easily. It should get converted to ion very easily. It means its ionization enthalpy should be minimum. And ionization enthalpy is minimum here. So it means a second is the most active. And the moment you get the answer C, because none of the other options has 2 as the first one. But why fifth is the least active non-metal? Because if you consider the right hand side, towards right hand side of the periodic table here, these elements actually gain electron, okay, and get converted to anions. Chlorine, oxygen, sulfur, phosphorus, all these actually gain the electron and get converted to anions. It means if they are very reactive, and all of these are almost, okay, although P block has metals, metalloids, and non-metals, these are normally non-metals, okay. Towards the extreme right, these are non-metals. Now, if these are very reactive, if these are very reactive, then they should release for very reactive non-metal at the right side. It should release a lot of energy after gaining the electron. Means very high negative electron gain enthalpy. Release means negative, very high. But opposite of that, for least reactive non-metal, we should rather have to provide energy to it, means the energy should be positive. It should be saying, no, I am not willing to react. Then we will force it by giving it some energy to react. Means the least reactive will have even positive or least negative. But here in this case, we have positive. Otherwise, we would have chosen the least negative. So this is least reactive non-metal. Okay. Then after that, this will be least reactive. Then more reactive will be this one. Then this will be more reactive. Most reactive will be this one, because this will release a lot of energy after gaining the electron. This will be most reactive non-metal, if it is asked. Okay, it is not asked in this question. Here it is asked least reactive. Any confusion regarding the concept I explained? It is clear? Yes. The answer. Next, the correct sequence which shows decreasing order of ionic radii of the elements is decreasing order. The rule I have already told you. The rule related to this question, I have told you, if you use that rule, you get the answer. Simple. Pratyush, Yashvedi, good. Correct answer. Amir, no. Vedant, no. Yes, Pratyush, that is the reason. Ariman, no. Sabya, yes. Kartike, no. Kavish, yes. Ariman, try again. The rule, okay, I'm telling you again. The rule is the size of isoelectronic species is directly proportional to negative charge. And remember, here it is given in decreasing order. If isoelectronic species higher the negative charge or lower the positive charge, greater will be its size. Okay, now Vedant, Samar, Shivani, correct. Arna, correct. Amir, think again. Higher the negative charge, greater the size. Size is proportional to negative charge. Kartike, size of isoelectronic species is proportional to negative charge. Now, if you see, these are isoelectronic species, but if you see the negative charge, this one has the highest negative charge, and this is not at the greatest position. Here it is at the greatest position, largest to minimum, small. -2, -1, +1, +2, +3. It means, yes, size is decreasing. Size of isoelectronic species is proportional to negative charge. It means B is the correct answer here. All are isoelectronic species because these have 10 electrons. Yes, Karthike, that's what I said at the beginning, that it is given in decreasing order. So you need to be cautious.
Yes, sir. Okay, sir.
Next one. The second ionization enthalpy of lithium, beryllium, boron, and carbon are in the order. You can try first before I tell you. You need to consider the hint I am giving. You need to consider after losing one electron, whether it gets more stable or whether it gets less stable, or whether after losing two electrons it becomes more stable. That will help you to answer this question. Yes, correct answer. Write the electronic configuration. Write the configuration of lithium, beryllium, boron, carbon, and then write the configuration after losing one electron. Arna, yes, correct. Pratyush, Atman, you trying? Now look here. Write first configuration of all these four. So normal configuration of lithium, beryllium, boron, carbon. Lithium has three electrons, beryllium has four, boron has five, carbon has 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1, 1s2, 2s2, 2p2. Okay, 6 electrons. But it will, when it loses one electron, there will be one less electron, and the electron always goes away from the outermost shell. It is not opposite of above principle. Okay? The electron will get removed always from opposite shell. So Li plus will be 1s2. Pe plus will be 1s2, 2s1, and boron plus will be 1s2, 2s2, and carbon plus will be 1s2, 2s2, 2p. So this is first, and then it will lose another electron. Okay? That is the question. Second ionization enthalpy. So here we are talking about here this energy by losing this electron. Now it is, remember, it is given in decreasing order. In these question options, it is in decreasing order. Now see here, from here to lose one more electron, this is already in a stable state configuration because 1s2 fully filled orbital. So this is very stable. After losing one electron, here it became very stable. So it means now it will require a lot of energy to remove second electron, lithium. Okay. This one is not complete shell because it would have been 1s2, 2s2, 2p6. Shell is not complete, but here first shell is complete. This is helium configuration, noble gas configuration. Noble gas configuration is very stable. So don't get confused that here also it is fully filled. No, here it is just one orbital fully filled. Here it is noble gas configuration. It means the highest second ionization enthalpy will be of lithium. So you narrow down to A and B. A and B can be correct. Okay. Now come to beryllium. Now, in all, beryllium is at the end, so leave it. You need to consider which one will be correct, whether carbon or whether boron. So consider these. Which one will require less energy? So obviously, this p orbital is much greater than s orbital. So in p orbital, the electron is away from the center. So this will require less energy as compared to boron. Boron will require now, B plus will require more energy because here the electron is in s orbital and that too fully filled s orbital. Here it is just p1, it is not half filled or fully filled, and also the p orbital is greater in size. So it means lithium will require maximum, after that boron, and then carbon, and then barium. B will be correct. If anything is not clear, let me know.
So can you please explain it again?
Which one? Which part?
Sir, why is the answer B option and not C option?
Not C option. C
Yes,
then
sir.
C is not option anyway possible. Okay. Now you need to consider why between these two. Okay. So otherwise, is it clear that lithium part is clear why it is maximum?
Yes.
Okay. Now B plus and C plus we need to discuss. B plus it has fully filled orbital. Okay, not shell, but orbital is fully filled. So obviously it will require more energy. As we talked about that if P is, for example, half filled or fully filled, it will require more energy. Similarly, here S is fully filled, it will require more energy. P is not fully filled, it will require less energy. So it means carbon plus will require less energy than P plus, which is
Okay, sir.
moreover, P orbital is greater in size. So P orbital S is this one 2s and P is this. So in s orbital, the electron is very close to nucleus as compared to p. In p, it can be far away. So it is easier to remove as compared to s. So both the reasons lead to the answer to B. Next, which of the following is the largest in size? Largest in size. Hmm, no, Vedant. Samarth, yes, correct. Yash, I think I was looking on the previous answers. Just a second, let me have. Okay, Kavish, correct. Arman, correct. Yush, Pratham, correct. Yash, no. Devyansh, correct. No, Devyansh, no. Not correct. Pranav, correct. Yush, no. Lemuel, correct. Kavish, Shabd, no. Kavish, no. Sorry, Kavish, correct. Kartike, no. Sabri, yes. Okay. Now understand how you will see the size here. These two are isoelectronic species. Both have 10 electrons. And out of these two, we know that greater the negative charge, greater the size. So at least here we know that this will be the case. Now, these two, These two again are isoelectronic species, 17 plus 1, 18, 16 plus 2, 18. And greater the negative charge, greater the size, means S2 minus will have greater size. Okay. So basically, here you have, this is not exception like lithium and magnesium, because in case of lithium and magnesium there is huge difference, percentage wise huge difference in number of protons, 3 protons to 12 protons. Okay, four times protons. Here there is not much difference from 11, for example, to 16, and sorry, 8, and if you are talking about number of protons, then yes, 16, and here you have number of protons, 17. So not even double, not even double. So the force of attraction will not be as great in this case when you move from sodium to chlorine, for example, as it was in case of lithium and magnesium. Do you remember I talked about that lithium plus and Mg2 plus I compared? I said that Mg2 plus and lithium plus Mg2 plus will have a smaller size. Why? Because the number of protons, 12 protons, have much higher force of attraction. Here also you might say that here also we are moving from 11 electrons, for example, if I am not considering the ionic form, I am considering only the protons. If I am moving from 11 to 16 or 11 to 17, there will be greater force of attraction than chlorine and sulfur ions should have smaller radii. No, here the force of attraction is not very high because the difference in number of protons is not too much as it was in lithium and magnesium. 3 to 12 is 4 times and 11 to 16, 17 is not even 2 times. So that's why these two will have greater size. And between these two, S2 minus will have greater size. So actually it is like this. So there is no exception here. It is a straightforward question based on in which period these are, whether it is left side or right side of the periodic table, and amongst two isoelectronic species, first set here and first set here, which one will be having greater radius? If anything is not clear, you can ask again. Good. Next one. Which of the following is the largest in size? Again, similar question. Good question. Okay, Yash Bedi, correct answer. Kartikeya, correct. Kavish, correct. Good. Subway, no. Basically, these are same group element and two electrons have been removed. So there is nothing like that you will consider. It will be similar to their neutral form. Okay. So in 16th group, you have oxygen, sulfur, selenium, tellurium, polonium. And when you move down, the group size increases. Because you are removing same number of electrons from all, the trend will remain same. Out of these four, polonium is not given there. Out of these four, tellurium 2 minus will give, will give you the largest size. Next one. The correct decreasing order of first ionization enthalpies of five elements. Decreasing order, remember. Just draw these in your copy where these are placed in the periodic table with their relative positions, and then see whether you can get the answer or not. Okay. So this is for your reference. You can use this one on the screen. Decreasing order of first ionization enthalpy. Yeah, many correct answers, almost all correct answers. Yeah, almost. Just telling you. Subway, Yash, Arna, Laksh, Yash. Yeah, problem. Samar. Almost all correct answers. I'm not able to see just due to some lag here. Some yes. Devyansh, no. If I missed your name, you can post it again. Kavish, no. Ariman, no. Remember, these are given in decreasing order, so you need to be careful. First ionization enthalpy increases across period, decreases down the group. Increases across period, increases left to right. So you can shortlist C and E because fluorine maximum ionization enthalpy out of C and E you need to find out now. Okay, Kavish, Devyansh, Laksh, correct. Ayan, correct. Ariman, no. Now remember, what is, you know that nitrogen first ionization enthalpy is greater than carbon. So anyway, C is not possible because this is wrong. Nitrogen has first ionization enthalpy even greater than oxygen. Nitrogen is rather here. So it has greater than carbon. C cannot, E cannot be. It is C. But this one, that why beryllium has first ionization enthalpy greater than boron? Because as per the trend, if you are moving towards right, boron should have greater ionization enthalpy than beryllium. Okay? So if you see this part, you might get confused that yes, in this part, this looks correct, but that is the exception. And this exception we talked about during the theory class. Yes, Pranav, C is correct. C is correct. Okay. But why this is so that boron looks to have the greater ionization enthalpy, but beryllium, again write the configuration and you will get the answer. Beryllium 4, boron 5, the configuration 1s2, 2s2. Boron has 1s2, 2s2, 2p1. And this is we have talked about. In beryllium, it is the valence electron is in s orbital. However, in boron, it is in p orbital, and that too not half filled or fully filled. So this is a stable configuration, will require greater energy for removal of electron. So that's why this is correct. Beryllium will require greater energy than boron. So this is the exception. Next, the correct order of decreasing electronegativity values among the elements beryllium, oxygen, nitrogen, and magnesium is decreasing electronegativity. Remember, so there's diagram. You can consider this diagram. We are talking about here beryllium, oxygen, nitrogen, and magnesium. Decreasing. Okay? Electronegativity decreases down the group, increases across the period. Electronegativity. Okay. Any correct answers? Karthik, Pratham, Avesh, Arna. Okay. So you apply the rule here. Simple rule. Electronegativity, and because we are talking about decreasing, it increases left to right, so you will draw the arrow like this because we have to move like this, decreases in this. Then again electronegativity decreases down the group. So means oxygen first, then nitrogen, then beryllium, then magnesium. Oxygen is given as 2, nitrogen is given as 3, beryllium is given as 1, magnesium is given as 4. 2, 3, 1, 4. First is correct. A. Next one, considering the elements B, C, N, F, and Si, boron, carbon, nitrogen, fluorine, and silicon, the correct order of their non-metallic characteristics. No non-metallic character. Okay, so if I see whether I have that, yes, I have. So we are talking about here boron, carbon, nitrogen, fluorine, and silicon. Oh, no, sorry, silicon. Decreasing order. Normal will be mm, you correct answers. Okay. So metallic character is maximum here, and we are talking about non-metallic character. Okay. So non-metallic character is maximum here, minimum here in the periodic table. Okay? Minimum next. Because it is given in decreasing order means arrow will be like this, non-metallic character. Okay. So many correct answers, out of which Divyansh, Pratham, Arna, Sabir, Laksh. Okay. So it's about this what you talk about. After fluorine, you have nitrogen. After nitrogen, you have carbon. After that, you have boron and then silicon. Now, you might ask one question. Okay. C and D, between C and D, actually, you can ask the question. That, okay, it's fine that fluorine will have maximum non-metallic character because it is on the top right. Then after that, nitrogen, after that carbon, then why can't we go to carbon to silicon and then silicon to boron? Because it is decreasing in both directions. It is decreasing in this direction also, it is decreasing in this direction also, in both cases. To here up to carbon, it is fine. Fluorine, nitrogen, carbon, it is decreasing. But when we are at carbon, down the group also it decreases, and towards left also it decreases. So which one will have less non-metallic character? Okay, whether boron or silicon. For that, you need to consider that non-metallic character is actually how easily it can donate electron or how movable the electron is in that element. Okay? So non-metallic character will be least if its metallic character is higher. And you know that silicon is actually a semiconductor. Silicon is actually a semiconductor, means it conducts electricity more than boron. So it is more metallic, means less non-metallic than boron. Those concepts will apply here, that metallic character is related to how easily the electrons can move to conduct the electricity. Boron is in second shell. So another point you need to remember, that this is second shell and silicon is third shell. So third shell, it is easier to lose electron for conduction of electricity as compared to second shell. Second shell will have higher non-metallic character. Any confusion? Let me know. Because in such cases, students get confused that after carbon, it can be down also and left also. In both cases, the non-metallic character will decrease. But then you will consider how easily it can lose electron. In third shell, it can lose easily. It means metallic character is higher, non-metallic character is lower. So non-metallic character is lower. We are talking about non-metallic character.